Now students, we'll discuss second application of Gauss theorem. The second application is electric field due to a uniformly charged infinite plane sheet. Look at students, let A, B, C, D, that is a small portion of infinite charged plane sheet. ABCD is a charged sheet. Okay, it is charged, but we know for getting flux we have to apply Gauss theorem, and Gauss theorem is always applicable when charge comes in closed surface. So around the sheet we'll assume a cylindrical closed surface, and this cylindrical closed surface is said to be Gaussian surface, this one. Okay, now students, this cylindrical closed surface release the electrical flux, and flux will release from three different paths. This is called first circular path, it release flux, this one. This is called second circular path, it also release flux, and this one is called third curved path, that also release the flux. So applying Gauss theorem, how much flux when charge comes in closed surface, it release flux. How much flux is released? Phi equals to closed integration of E dot ds. Okay, that flux released from complete Gaussian surface. We know students, Gaussian surface is releasing flux from three different paths. Okay, so E dot ds, closed integration of E dot ds will break in three parts. E dot ds from first circular path, E dot ds from second circular path, E dot ds from third curved path. This is a releasing flux from all different paths. Okay, now students, look, we know at circular path E and ds are in same direction. When we put there a test charge, so plus repel to that, like charge repel each other, so this will be the direction of electric field, and its area is always normal to the surface that side. Okay, it means at circular path E and ds are in same direction, and when two components are in same direction, theta should be 0. So when we remove dot, there comes cos theta, EDS cos theta, EDS cos theta, and EDS cos theta. At circular path E and ds are in same direction, so theta should be 0, cos 0, and at curved path its area is normal to the surface upwards, and electric field is that side. The angle is 90. For this curved surface, E and ds are perpendicular, so theta should be 90. We know cos 0 is 1, it remains EDS. E comes outside from integration. Here same, EDS, E comes outside from integration, that is constant. There will be no integration of constant, that's why electric field outside. And cos 90 is what? 0. Now students, integration of ds. On account of that, we know the formula. Integration of dx is what? X. Okay, on account of that, integration of ds is what? S. Integration ds of is S. Es and Es, 2 times Es. So how much flux will release from this cylindrical Gaussian surface? That is phi E equals to 2Es. So phi equals to 2Es. That much flux from release this Gaussian surface. Now students, again we are going to apply Gauss theorem. Phi equals to Q by epsilon naught, the first main form. Phi equals to Q by epsilon naught. Here we'll make some change. Charge lies. Look at students, this is the sheet, and sheet having surface area S and that charge Q. So charge lies on per unit area is said to be surface charge density, represented by the sign sigma. Charge lies on per unit area of this sheet is said to be surface charge density, and this symbol is said to be sigma. So students, for getting Q, sigma into S. So here I am going to put sigma S. Compare both. This is the flux and that is also flux. When left hand side equal, right hand will also equal. Compare equals to second and third, both showing the flux. So 2Es will equals to sigma S by epsilon naught. S to S cancel out. So we'll get E equals to sigma, 2 comes in denominator. So we'll get vector E equals to sigma by 2 epsilon naught, where sigma is called surface charge density, charge lies on per unit area, while epsilon naught, that we know, permittivity of free space, having the value 8.85 into 10 to the power minus 12 coulomb square upon Newton into meter square. So that much flux will release from this closed surface, and electric field due to infinite plane charge sheet will give by this formula, sigma by 2 epsilon